Okay, I wanted to make another video. I get a lot of ball earthers saying that's not how it is, and this is how it is. This is sky maps. If you actually look into sky maps, doesn't matter what star program you use, this is how the sky works. Okay, when you're at the equator, when the sun, this is the southern pole, this is east, this is north, this is west. Okay, when you're at the equator, when it's winter time in the south, the sun is in the north, 20 degrees. See, every one of these is degrees, 20 degrees, 30 degrees, 40 degrees from the center. The reason why an equatorial mount works is because it works to the center. You are the center. Okay, that's the only reason why it works, is because it is the center of the sphere. You're always in the center. Okay, you understand that? When I'm at, for an example, this you can use all over Earth. Okay, the pole, okay, that is at the equator. When we go 10 degrees, 20 degrees, 30 degrees, 34 degrees, okay, because if you count these 10 increments, this pole star is 34 degrees to the center of the other side, which is the northern side. Okay, so it's in the center of the sphere, and that's why the equatorial mount will work on a flat plane or a ball. It doesn't matter, it's because it's going to the center. Now if we look at sun angles, okay, if you look on this white sheet of paper, this is east. Well, then the next one is 100 degrees, 110 degrees, and 120 degrees. So the sun rises in the summertime 120 degrees, okay, over my head, and then it sets 240 degrees on the other side. Okay, in the wintertime, it's rising nearly 60 degrees. Okay, 60 degrees and setting 300 degrees. Okay, so it doesn't matter where you put this, anywhere on the earth, this is how it works. And you can travel from the equator all the way to the South Pole. This is the North Pole, all the way back to the North Pole. You understand that? And when I'm under the North Pole, the sun in the summertime in the north is spinning around this loop, okay, at its highest point. That's why you're getting a 24-hour sun. Okay, and the southern, okay, this is the sun. Well, if you're on the southern hemisphere, that is below the perspective, okay, because it's further than the distance it is from the equator, or from the pole to the equator. Once you go past that 10,000 kilometers, it diverges, and things appear to, it's like looking down a hallway. We know what it is, it's parallel lines, but it appears to touch each other. There's a difference between appearing and what's actually happening. We know the hallway is the same height as what it is at the end, but it's like a postage stamp, it's tiny. Okay, it converges. The sky rolls like a scroll. Okay, it's like you're in a bird cage. And when you go north to south, this is what happens. In a simulation, you can't say it can't work in a simulation, it can. Because you can keep running on that flat surface, and that's basically what's happening. Okay. So, but doesn't matter in the northern hemisphere as well. Okay, this is the northern hemisphere when you're 10 degrees. Okay, let's have a look at the sun angles. Okay, When you're 10 degrees, they're the sun angles for the equinox, the summertime and the winter time. Okay, 20 degrees, because if we look on this end, okay, we're going 20 degrees below the horizon. This is 20 degrees above the horizon. The center is you. That's why an equatorial mount works, is because wherever you are on the plane, you are in the center. Okay, if you're in the same location as what I'm in, we're both going to get the exact same observation. You understand that? And depending on where you are on that Earth, 90 degrees is always up. So you always, the ground is moving and the sky is moving at the same time. Okay, you understand that? Going from the north to the south. A simulation can work like that. That's plain and simple. Your perspective on how it works is that the Earth is a tiny little speck within this sphere, okay, and the angle of the Earth, when I walk to the pole star, the angle of the Earth is 10 degrees now, okay? That little tiny pinhead in the center, the angle of it will be like that. Now I'm at 20 degrees and 30 degrees and 40 degrees and 50 until I get to underneath the pole star. You're basically saying that's the angle of the Earth until we go back to the equator on the other side. Well, then it's upside down. Well, this is north and that is south. That actually flips if you go up the other way. So it would feel like north is south and south is north. But anyway, that's why I believe it's a simulation, but it definitely can work in a simulation. Okay, you can't say it can't work, because it can. That's a simple demonstration of how it can work. Thanks for watching.